Hello, and welcome to the AI Engineering Podcast, your guide to the fast-moving world of building scalable and maintainable AI systems. Your host is Tobias Macy, and today I'm interviewing Spiros Xanthos about architecting agentic capabilities for operational challenges while managing production systems. So, Spiros, can you start by introducing yourself?
Hello, everybody. My name is Spiros Xanthos. I'm one of the founders and the CEO of Resolve AI. As a background, I've been working in dev tools and observability most of my career and started working on Resolve AI about 2 years ago with the goal of building agents that help troubleshoot production issues and help humans run production systems by taking over the stressful parts and the toil of the work. So I had exposure to ML and AI over the years because I worked in observability for a long time.
And do you remember how you first got started working in the ML and AI space?
Previously started two companies in the space, one a log analytics platform out of my PhD. That company got acquired by VMware. And then in 2018, co-created OpenTelemetry and built a company around it called Omnition. And, obviously in observability, we always had the goal of using, let's say, machine learning to understand anomalies and to point them out to users. And ideally, maybe try to connect the dots and tell them what's going wrong. But in reality, that never worked beyond, let's say, maybe crossing thresholds and understanding that something is wrong. It was impossible to really do the work that humans did, right? Of looking at their systems, looking at the data, looking at telemetry to understand how, let's say, a violation of a threshold relates to the root cause. So I was always interested in the topic, but I think with Resolve AI, we took a very different approach. Obviously, with the advancement of LLMs, we decided to try to build agents that work autonomously. They use all the human tools and try to not just essentially do simple tasks such as anomaly detection, but they try to reason through very long running kind of tool call processes to get to an outcome.
And now, digging into Resolve specifically, can you give a bit of an overview about what it is that you're building and some of the story behind how it came to be and why you decided that that was where you wanted to spend your time and effort?
Yeah. So when my last company was acquired by Splunk, I ended up being the general manager for Splunk Observability, which was a large engineering team and a production system that our users relied on to run their own software systems. So we had very high reliability requirements. And at scale, what was happening was that our own engineering and SRE team was spending the vast majority of their time troubleshooting our production, let's say, or running or maintaining our production, rather than building new features. And not only that, you had periods of time where things would get unstable enough that we would freeze pushing to production. And we had like a 6 month period where 90% of our SRE team resigned due to burnout. And all of that, despite unlimited use of our own tools and basically unlimited data to troubleshoot production. So the realization was there that despite working in observability all these years and building tools that gather lots of data, that data by themselves are not useful, right? Like humans have to provide all the context and connect the dots. And that's a very, very hard problem at scale. So that's how the idea was born, from our own pain to some extent, and the realization that data alone without context and knowledge of the entire software system and how all these the different types of data connect with each other leads to answers. That's what came to was the initial idea behind Resolve. We decided to maybe rethink how to approach the problem of troubleshooting alerts and incidents when something goes wrong, and decided to do that by building agents that basically connect to all the human tools, source code, telemetry, logs, metrics, traces, infrastructure. These agents work in the background all the time, build essentially a deep understanding of the whole production soft system, from code to backend databases and everything in between. They try to understand and extract all the tribal knowledge that exists, that usually is spread out across tools, and use all of that to essentially be on call. And every time something goes wrong, start an investigation, get you to the root cause, and provide an answer of how you should fix the problem. That's kind of the high level architecture of how the system works. And of course, then many, many, many complexities in how to make it work.
And in terms of the operational aspects, as you mentioned, we have a lot of investment in being able to generate, collect, curate display a lot of data about how our systems are running. As you said, it is still a very manual process. We do have automated systems in place to be able to do things like threshold based alerting or simple machine learning heuristics around things such as exceeding a certain number of standard deviations of norm. But I'm wondering if you can talk to some of the critical failures in the capabilities that we have in the types of systems that we use to manage the reliability and overall kind of operating capacity of the platforms that we rely on for our applications.
Yes. So I'll give you a few. First of all, these systems are designed to collect as much data as possible. And the way that humans use them is essentially either by querying the data directly or by creating, let's say, dashboards that hopefully maybe highlight important KPIs and by setting up alerts that fire when something is wrong. But these tools don't generalize very well. What I mean by that is that you have to create very, very specific, let's say, dashboards with very specific charts that maybe indicate health or potential problems. And then you have to create very, very specific alerts with static or dynamic thresholds, but still they monitor one specific metric and then they don't generalize very well, right? As a result, what ends up happening, you're either in a situation where you kind of set the alerts to be very sensitive so that you catch problems quickly and then you get overwhelmed by alerts and humans do not know where to start. Or if you try to be much more, let's say, specific, then you end up missing a lot of the challenge, a lot of the problems, and you become very reactive. In either case, humans are drowning in alerts and data, right? And every time something goes wrong, either you have like a lot of experience and expertise about the system and you can intuitively maybe get to the right answer, or if you're a new engineer, a new SRE to the team, usually have like this very hard cold start problem where you know something is wrong, but you have no idea where to start from, right? You have to both understand the underlying, the monitored, let's say, software system, its architecture, the dependencies, but also have to become like an expert in these tools and their languages and, how to essentially query all this data to get an answer. How does that manifest in practice, right? Oftentimes you add a new developer to your team and it takes them a few days to submit their first PR. But it takes them then 6 months to be primary on call, right, and be effective. And why is that? Because there is all this knowledge that is very specific to this system and all this data that you have to familiarize yourself with in order to be able to like troubleshoot these systems on your own.
To that point of needing to troubleshoot on your own, it requires a lot of acquired experience, often acquired with a lot of stress and anxiety. And I'm curious if you can talk to some of the ways that bringing an AI agent into the picture can help to alleviate some of the need for all of that broad context, or at least help to surface the contextual relevancy of that context so that somebody who hasn't already been working on operational systems for decades can actually understand and interpret the findings that the agent is providing to them.
I think that at this point, the aim is not to make a person who's, let's say, not a software engineer or an SRE, troubleshoot production systems. There's a secondary goal which I can talk about, but the primary goal here is that we should have agents that can learn all the context, they can have all the tribal knowledge, that they can understand the entire software system, and then they can do all the hard work and the heavy lifting of actually connecting the dots across all the different systems, right? Looking at code changes, looking at infrastructure changes, looking at configuration changes, connecting that to what they see in logs, what they see in metrics. Sometimes, with what they see in how, let's say, the infrastructure and the dependencies of the cloud work, and trying to essentially develop the theories of what might be causing the problem and getting you to the root cause, right? Humans still have an input, and humans maybe are still the best at deciding among two or three options which one makes the most sense, right? And maybe even guiding the agent further to narrow down to one theory and then help the agent provide a fix. But there are things that the agents do a lot better than humans, right? They can operate at a much higher velocity. They can connect many more signals. They don't have biases actually sometimes, right? On what they should check or not check. But still, humans are still at the wheel, let's say, most of the time. Now, to your point about people that maybe don't have like the deep expertise in production systems and software, I do think actually what we realized and what we saw with our customers is when you deploy these agents that now give you like a very easy interface, right, in English, to ask any question about your production system, whether it's related to a problem or not, right? What that creates is actually an ability for anybody, whether they're deeply technical or not, to actually get self-service in anything they might want to ask about the system. What we see, for example, around sales team is using Resolve instead of like tapping somebody's shoulder to understand like a new feature that was just released, right? Or to ask, give me a summary of whether my customer has faced problems in the last 24 hours because somebody complained. So you have that as well, right? But that's more to answer, let's say, more basic questions rather than like go and troubleshoot an incident and resolve it, right? That still requires engineers and SREs. But the agents make it a lot easier and a lot faster. And what that avoids is both, like, say, the burnout and the stress of like being paged in the middle of the night and not knowing what to do, but also it helps avoid the constant interruption of escalations and paging the wrong people sometimes, or multiple teams trying to troubleshoot the same problem, although it comes maybe from one specific area of the system.
Because of the fact that we do have a lot of technical and operational investment in the systems that we rely on to provide the scaffolding and operating context for the applications that we care about, some of the big names in the space obviously being things like Grafana, PagerDuty, Splunk. Why is it necessary to create a completely new system in the form of Resolve to provide these agentic capabilities rather than incorporating that as some sort of feature or plugin to those existing systems that already have a lot of the operational data that is necessary or that people are currently relying on?
First of all, this is, in my opinion, much broader than observability solutions, right? So what we're doing here is we're building agents that do the work of humans, work alongside humans, and relieve them of a lot of the toil of running a production system. We're not simply just like advanced systems like Resolve are not like simple tools that translate maybe English to a query to get back an answer and continue on your own, right? These are like autonomous agents that can connect the dots across multiple of these tools, learn about the software system the way a human learns about it, and create essentially this very deep understanding and expertise over time of how production runs and how to troubleshoot it. And to do that, first of all, you have to go across multiple categories, right? You have to go into code, you have to go into like CI/CD and pipelines and changes, you have to go into observability tools. Oftentimes, in each one of these categories, you have multiple of these tools. So it's very, very hard for any one of these tools on its own to actually help you beyond its own data, right? Because a human does not rely just one of these tools to get answers or to run production. They rely on the union of the tools and the most appropriate for every question. So to me, this technology is way more advanced than what observability does, and all the prior work I did myself. In that, essentially, it can reason almost as a human for this particular kind of set of problems. Now, obviously, existing vendors could try to build these solutions themselves, right? I think still they're going to be limited mostly by the fact that they will probably try to build it for their own data. But there is also the other challenge, which is that this is a very hard problem to solve, and it's a very, very different type of problem than essentially being a database for large amounts of data. The models have advanced a lot, but it's still a very, very hard problem. Like, as easy as it is to build a demo, an AI demo, it is that much more harder to build something that works well in production. Like, just in our case, we have a team of like more than 50 engineers, 10 of which came from like top labs building agents for a while. And it takes like both focus and talent to solve this well. So I think if anyone else or these bigger companies want to solve this as well, they probably have to assemble a equal amount of talent and focus on this problem, right? And I haven't seen it happening so far yet.
In terms of the overall industry, as far as building agentic applications, there is still a lot of evolution and discovery happening as far as how to actually build those systems and make them reliable and achieve the goals that you set for them. And I'm curious how you approach the overall problem of identifying and evaluating and proving out the various architectural patterns and paradigms around how to actually build an agent based system and some of the selection criteria that you had going into that.
So, first of all, it's a very hard problem. You're right. And especially when you're dealing with multiple modalities of data, like we do, it is an even harder problem because essentially you have to have multiple agents, each one of them maybe specializing on one type of data, let's say code logs, metrics, infrastructure. And you have to combine the data across all of them, right? And reason across tool call chains that sometimes go like 100 or 1,000 tools deep. And there is no really well-established patterns of how to do this well, right? All of us who are working on this were paving the way of how these systems should be built. Now, what we found, or the way we architected the system and what we found to work very well, is first of all, in our case, I think there's a simple approach that maybe some take, which is take an LLM, run telemetry through that, summarize and maybe correlate what you see. And that can be quite useful actually to humans because they get a much shorter set of data that they can reason over. But then that only addresses a small subset of the problems, right? Our approach has been to actually use all these underlying tools to first build an understanding of how the production system looks, right? Understand every host, every dependency, the application to infrastructure also dependencies, every change that comes into the system, and also go to all these other tools and extract, let's say, the tribal knowledge that exists. But not just from the tools. As humans use Resolve, we try to actually learn from the questions they ask and the feedback they give us, right? So that allows us over time, first of all, to build like this deep understanding of the whole production system. And to me, that's a prerequisite of building something very effective, right? Because then you have like, let's say, this graph that the agents can use to plan, backtrack, reason about the problems they're solving, right? So that's kind of the foundation for it. Then we built a lot of like agent infrastructure in terms of planners, meta planners, things that understand knowledge and have a very powerful memory system that lets the agent become more and more effective every time they perform a task, right? So if when they make a mistake, they make the mistake only once, right? And when they find something that works well, then they remember that forever. And then we broke down the problem into multiple agents that each one of them specialize in one task. And for each one of these agents, we kind of have a hill climbing approach where essentially we keep improving, let's say, the reasoning and the models to achieve like very, very high accuracy in terms of like what this agent does for the data it looks after, right? Like logs, code, metrics, etc. And then we put a lot of effort then on top of all of that to have like essentially a reasoning engine or a reasoning agent, if you wish, that given a task or a problem, it knows how to call all these tools that are available, all these underlying agents, and drive this very, very long process, long horizon kind of agentic process to get an outcome. So that's kind of rough the architecture we built, and it works very, very well.
You raised an interesting point of the variance of the actual context in which the agent needs to operate because everybody has their own specifics of how they actually deploy and configure and manage their operational environment, where maybe there is a large corpus of people who are using Kubernetes, so you can maybe make some assumptions about how the capabilities that you have to be able to retrieve information. But there's, even given that common substrate, there's a huge amount of variance in terms of what they're actually using for generating or collecting metrics, what their log formats might be, their naming patterns as far as how they identify the different applications that are running, the network topologies or overlays that they might be using. So even just within that assumption of we're only going to target Kubernetes environments, there's a lot that you have to deal with. And then if you also expand to we're going to support various cloud providers and their core compute primitives, and maybe even expanding out to some of the serverless capabilities or on premise use cases, that's a massive surface area to be able to identify and service. And given the potentially exponential search space that you need to deal with, what are some of the ways that you're thinking about managing the complexity of your product and some of the ways that you're thinking about the framing and customer targeting of what the presumptions are of their operating context to enable your tool to do the job that it was provided?
Yeah. First of all, you're describing the problem very, very well, right? This is by far the hardest product I ever tried to build. And I think also all the challenges you're describing is the reason why, in my opinion, doesn't make sense for most people to try to attempt to solve this themselves, right? Of course, there are subsets of the problem that it's worthwhile for developers to try to build and solve on their own, but the totality of the problem is very, very hard because of all this complexity you're describing. Now, in our case, I would say, like at the high level, we broke down the problem to two parts, right? One is like understanding of the environment and our ability to go and extract as much of that tribal knowledge or learn about as much of that tribal knowledge using the existing tools and via the interactions with humans. So we have agents that run in the background all the time that understand changes, understand dependencies, look at all the tools and look at the human created knowledge, whether that's in the form of dashboards or the form of prior incident reports or in the form of even architectural diagrams, and try to essentially create this understanding, as deep of an understanding as possible, and hopefully as close that experienced human engineers have about the system. And that's kind of the baseline. And then we have these agents that can reason almost on first principles, right? Our system is not like a runbook automation tool. It can start with any task or any symptom or any alert or any incident, and then tries to actually explore the space by starting at very high level set of hypotheses or questions to ask, and then based on the answers, it iterates and goes into more and more specific kind of investigations to narrow down the scope to something very specific. Not that much different from what a human would do, right? But to do that well, you need to have this underlying context and understanding, and you need to be able to provide the right context also at the right time to the right agent to do this well. And we found that like this kind of hierarchical investigation system and the background agents that create baselines and understand the environment are a very good set of primitives for making this generally applicable. And the third one maybe is that we also found that it's very, very important for the agents to be able to learn on the job. So they have to be effective day one because they have all the training, let's say, about like existing systems, and they can maybe quickly understand the environment. But it's very, very critical that every day and every time a human uses them or interacts with them, they become better by learning from it.
That brings up an interesting question as well, as far as how you thought about the means of discovery and patterning the agentic capabilities and agentic discovery patterns after the ways that a human operator would. And I'm wondering what types of research or user experience studies you did to understand how best to actually map that human pattern of discovery and debugging into the ways that the agent is actually executing those same behaviors.
Yeah, first of all, many of us worked in building tools that humans used all these years to do this, right? Like I mentioned, we're co-creators of Open Telemetry, we built Splunk Observability, before that built a log analysis tool. Most of us have been on call and managed and run large production systems. So we had like first-hand experience in both the approach humans take, but also the tools that humans use and their limitations. And that helped us quite a bit in understanding what is the starting point and maybe how to go about solving the problem. Now, the other thing that is also true is that the agents have to use human tools to perform the task, right? Now, maybe there is a future in which we kind of evolve the existing tools we have and they're more appropriate for agents and they can move faster and the paradigm changes a bit, right? But for the time being, because we usually our agents drop into an environment that humans already manage and operate, they have to essentially be able to use the same tools, and they have to be able to approach the problem almost as a human in order to solve it effectively, because these are the tools that are available, right? So it's both the understanding of how humans solve the problem, but also is the limitations of the tools we have that were designed for humans. And to be honest, this is maybe a bigger bottleneck than the reasoning or inference that we have to do for the agents.
Context is one of the bigger problems to deal with when you're working with agents, because you can't just send all of the data that you have and expect that it will figure things out, because not the least of which is that you'll explode your budget in the process. But also, in order to make sure that the agent is paying attention to the most important things, you need to be as sparse as possible with the context that you're providing. Context engineering is the current terminology that people are using around that. It is the most complicated piece of actually building agentic applications, at least from my understanding and in my opinion. And I'm curious how you think about the appropriate structures and retrieval methods for being able to actually manage that contextual grounding to the LLM, especially given the fact that LLMs by nature are very forgetful unless you keep reminding them of the things that they're supposed to be doing and have to know to perform a given task.
Yeah, completely forgetful, right? They start over every time unless you pass something in context. So there are many techniques we use, right? Some of which are actually almost original research we did. Of course, you have to be very effective in like providing the right context at the right time. You have to be very effective in summarizing maybe the output of a step so that it doesn't blow up the context that by itself. You have to actually use oftentimes multiple agents, and for each agent you pass a very specific context and you expect a very specific answer, and then you use that as part of a larger process, let's say, that runs on top. But I would say, okay, if I were to summarize, I think very, very important to have like a powerful knowledge and memory system that remembers a lot of important information and context. And then you have to have a very sophisticated retrieval system to know what to use out of that, depending on the task at hand, right? Then you have to worry a lot about not blowing up your context by having a lot of unnecessary information. So it's very, very important to distill maybe the outcome of a step down to the essentials and then use that for subsequent steps. And I would say then there is kind of even traditional distributed systems, maybe paradigms that you use here, right? Like if multiple agents get involved, do they share the whole context? Do each one of them has its own context? Is there maybe shared context across a subset of the agents? And it becomes a very complicated both like retrieval but also software engineering problem. And I agree with you, like it's one of the biggest challenges, especially in production systems, right, where like your input data are practically unlimited, right? The volume of logs that you might be dealing with is practically unlimited. So how do you essentially architect a system that does this well?
The other interesting element of that challenge is that you need to be able to even have access to that data in the first place, which brings up the question of integrating with the customer's systems. And I'm wondering how you're thinking about that challenge as well, as far as reducing the onboarding effort for the customer while maximizing the benefit that they get from as little work as possible.
Yes, so that's a very, by the way, in our case, it's kind of one of the principles on which we build Resolve. Like we want to have the minimal amount of effort from users in order to onboard us to a system, right? Which means that we have to do a lot of work on our own in actually training our agent to use all the existing tools that might be available in an environment, right? Which requires both depth. The agents have to be very good in querying and understanding logs, right? But also breadth. They have to be able to know all the logs, common log tools that people have out there and they use, right? And sometimes they have to be able to use custom tools as well, right? Without the user having to do a lot of work or any work for that matter. So that means like we have to put a lot of work up front on our side so that the agent comes pre-trained as much as possible to use all these tools. And of course, then we also have to we put a lot of work in making sure we respect the limitations of these tools. The agent should not actually impose undue burden, let's say, onto these tools, right? Maybe it shouldn't run unnecessary queries, right? And it shouldn't run stupid queries that are too broad, right? That humans would avoid otherwise. So there is that as well, right? Like the rate limits and how intelligent the agent is in using these tools, right? So it doesn't like create problems for the humans who are using the tools, or creates unnecessary complications when it gets onboarded.
And for anybody who has used LLMs for any extended period of time, you also have the challenge of the LLM getting stuck in a loop. So, speaking from recent experience, I ask the LLM, make this change to this file to be able to achieve this outcome. And it just gets stuck going back and forth between the same two solutions and can't realize that it's stuck in a loop. And I'm wondering how you think about some of those types of challenges as well, as far as the who is watching the watchers, where you are building a system to provide operational understanding and proactive capability to the end user. How do you then also use some of that capability to keep watch of yourself so that you don't cause your own operational problems?
Yes, I mean you have all the traditional challenges of building software here, right? Like, and you have to have good observability and you have to have good auditability of all the actions, right? So that you can troubleshoot all of these systems. But then this brings up another very interesting point that we found to be very, very important, which is that we make the agent always ground any answer it provides on real data, right? So when it provides an answer or a theory or like a root cause analysis for a problem, it always creates like a pretty detailed set of citations that the user can use to verify the chain of thought that the agent used to get to the conclusion it got. And this we found this to be very, very important, both for the agent itself to or the agents to prove to themselves, let's say, right, to their own system that the answer makes sense, but also for a human to be able to verify. And we found that it would be very important for creating trust with the humans because they always can verify an answer. If they disagree with an answer, they can even tell the agent why they disagree with the answer, and the agent can learn from it. But also over time, that creates more and more trust so that humans trust the agent because they have maybe seen a few times now that the way it works makes sense, right? And it draws the right conclusions.
Because of the fact that you are focused on augmenting and not replacing human operators, that also brings up the question of what is the actual user experience? What are the interfaces available to that human operator? And how do you manage a pleasant and useful handoff to the human operator without just saying, here's a bunch of stuff and dropping it on the floor?
Yes, first of all, yet another original problem here that is almost research, right? Because we don't have many good paradigms on how to do this, right? And simple chat is not sufficient by itself, right? Because you have rich data. Oftentimes, to verify an answer, you have to go through a lot of data points that, when tied together, create the answer. So it's not a simple interface. But the way we kind of approached it after a few iterations is that we have agents that work alongside humans. They can interact with humans and they usually provide quicker answers. And we have agents that work in the background. And in either case, we found that they have to be able to present in a very concise way an answer, but then have a longer, maybe, set of data that somebody can examine. But we also found that even for the background agents, it's very, very important for humans to be able to actually intervene in the process. As the agent runs in the background and does a lot of work, it exposes all the work it does. It exposes its current, let's say, thinking and its current state. And humans at any time can come and intervene, either send the agent in a different direction, or tell the agent that you're right about this, maybe go deeper. And that interaction mode is not easy at all, right? It's almost as if you're interacting with another human, right? In a way that is very natural to both. And we found a combination of essentially a very kind of rich in data, sometimes visual, some text, for a human to understand the state and the status and an answer, but also an ability to kind of jump into the middle of a background kind of agent investigation and provide guidance is very, very important, right? Which means that the agent has to be very responsive to that as well, right? And should be able to change direction in the middle of a task. But yes, also that creates something that is also very powerful, right? Because now humans can go to Resolve AI and ask any kind of question. Resolve is going to go to all the underlying tools, get the answer, provide it back, and humans now can operate at a higher level of abstraction, right? Not just for problems, but for any type of software engineering task that involves code and production. And that's extremely powerful if you get the interface right, because humans don't have to be now experts in these low-level tools and custom languages, and they don't have to be able to go through huge dashboards with many charts to try to eyeball maybe an answer, and they don't have to be able to try to correlate, let's say, across all of these, right? Is something slow because of a code change? Is there a feature flag that is on? Did something change the traffic patterns? You can ask a question, the agent is going to go and examine all of these and give you an answer or two about what might be going on, right? And this is very, very powerful. And I honestly think this is the future, right? Where agents become more and more autonomous. Humans now start operating at a level of abstraction that is higher, and they actually delegate most of these kind of tasks to humans. And then they're the ones who are kind of deciding what should be the next step, right? Or the final outcome.
Given the fact that you're focused on systems that are powered by software, you're empowering people who care about whether or not their application is running, whether they can deploy their application effectively. That also brings up the question of the fact that a lot of software now is also being written in conjunction with LLMs, and some of the potential for that to introduce new problems or security issues. And I'm wondering maybe if there is some bidirectional capability that you're thinking about as far as being able to feed some of the discovered operational characteristics and patterns of the system that the application is operating within, to then be able to help course correct things like GitHub Copilot agent that is iterating on a pull request, to be able to say, nope, I'm sorry, you can't actually do that because the system that you're trying to talk to doesn't even exist.
I think that the future looks exactly the way you describe it, because now you have agents like Resolve AI that create this very, very deep understanding of production, all the way from source code to how the system operates. And that context is useful not just when you run production or you can troubleshoot production, but it's equally useful when you're actually trying to make changes, right, via code. And the exact ways that this might manifest, you can think of it as the right context for the change I'm trying to perform right now, right? Or for the right test case to validate the change that I'm performing now. Or let's say the appropriate PR to fix a bug or to improve, let's say, the reliability of the system or the efficiency. But I think this is kind of where the future is, in my opinion. Agents like Resolve AI improve reliability for code that was generated by agents, but also providing the right context to those agents to actually be more effective when they make a change, right? Or when they reason about the code related problem.
And then the other aspect of a system like Resolve AI is that you're working in the context of something that is constantly evolving. People are adding new code, scaling up, scaling down, changing the labels on a particular metric, or changing the structure of log lines, which requires you to be able to adapt and course correct, as well as being able to maybe prune the set of tools that you need to have available to the agent because they don't even exist in the context that you're running, and you can cut down on some of the number of tokens that you're taking up by just even saying, hey, these tools might exist. And I'm curious how you're thinking about that iterative feedback loop and the evolution of your system as it adapts to the changes of the context in which it's running.
Yeah, this goes back to the way I was describing the architecture, right? So a big part of what Resolve does and does a lot better and differently than anyone else I've seen is that it actually models the entire software system. And to model the entire software system, it means that it captures every change that happens, every configuration change, every code change, and adapts its understanding of the environment constantly, right? Like one way to see this is like, why are runbooks not effective? Because they're always out of date, right? Because as soon as they're written, something changes in the system, and they're not applicable anymore, right? Or why do you have to spend so much time to maintain observability tools? Is because the things they monitor change all the time, right? And you have to constantly update alerts, dashboards, etc. And Resolve does all of that automatically. It models the system, it updates its understanding of the system constantly, like every few seconds, basically, and with every change that comes in, and also learns from humans, like I said, right? On top of all that, and to me, that's like maybe one of the most important things that we did to be able to be effective in a system that changes constantly, right? Sometimes thousands of times a day.
One of the other perennial problems of any sort of even observability based system, but especially when you're bringing AI into the mix, is the question of predictability of cost. To say, I would love to use Resolve AI. How much is it going to cost me? And how can I predict costs going forward? Obviously, costs can be highly variable when you're dealing with variable data collection. LLMs added an even higher degree of volatility to price prediction. And I'm wondering how you think about being able to mitigate some of that volatility in the costs that you're incurring by operating your system and pass on some of that predictability and confidence to your customers to so that they don't have to worry about accidentally spending $10,000 a month when they thought they were only going to be spending 500.
So, first of all, you're pointing out like a very challenging problem that observability tools have today, right? Because they charge by volume of data. More data doesn't necessarily mean more value, right? But yet, we find ourselves stuck in that situation and we have to pay all this money. So, having all this experience myself in observability, we decided that the way to do this is to essentially charge by the amount of work the agent does, right? Or the number of problems it solves for the users, and users have full control in how often they want to have the agent do the work for them, right? So it creates a lot of predictability and aligns actually the value extremely well to the outcomes that the human's aiming for, right? Not in an abstract way, okay, more data means more value, but actually specifically, right? Like it will solve all these kind of incidents, or it will respond to all these alerts for you, or it will troubleshoot all these problems for you. And we find this to be also create a lot of predictability and a lot of kind of alignment between value and outcomes that the users are expecting. And also gives a lot of control to users on how often or how widely they want to use the product. But to be honest, the most important thing is that because now Resolve AI essentially directly addresses maybe the most important challenge in delivering business software reliably, it is also very, very valuable, right? So if it does it well, honestly, it's way cheaper than humans, and it's a no-brainer for us to use it. So the outcome or the value of the task that Resolve performs is very high. So as long as we do it well and keep improving, humans want to use it more and more, right? Not less.
As you have been building Resolve AI, digging deeper into some of the architectural paradigms, the user experience paradigms, etc., and working with some of the early customers, I'm wondering what are some of the ways that your conceptions of an understanding of the overall problem space and the approach to it have evolved and changed, and some of the ways that you have maybe been surprised at false assumptions or misunderstandings.
So I try to keep track of things that I thought would be one way when we started versus that differently now. And there are many, many things that I thought would be different. Actually, not just technically. Like maybe I'll give you two high level things. When we started, it wasn't clear we can solve this problem well and we can go very far. And also, it wasn't clear to me that companies, especially larger enterprises, would be willing to adopt agents in production. I was surprised by how quickly, essentially, large companies were working with some of the largest financial institutions in the world actually leaned into AI and AI that goes into production, and they see the value in actually modernizing their operations. The problem itself, in some ways, it's a lot harder than maybe I anticipated. Like it takes a tremendous amount of AI talent together with, let's say, maybe more traditional observability and software systems talent to solve this well. Obviously, the models provide the baseline for being able to even approach this problem, but also the final outcome is very far away from what the models can do on their own. So we had to make huge investments in creating infrastructure for agents, investing on planning and reasoning, whether that's via improving the models or outside of them. And that's kind of the other thing, right? Like this is a much maybe harder problem than even I anticipated. Then within that, right, there are many, many interesting challenges that we found. But I would say that I'm very optimistic about the future in some ways. I think that despite of how hard this problem is, I think we still remain on an exponential curve of improvement. And I do believe that in a year from now, I mean, the way software engineering is done has changed completely already, right? But I think it's going to keep changing. And I'm optimistic in another way also. I don't think this change is going to result in like fewer people working in the technology. I think it's going to result actually in a much higher technology output, right? Maybe 100 times more, 1,000 times more, which in my opinion is very beneficial for the world because we're going to be able to solve a lot more problems via technology, and we're going to be able to improve the quality of our lives and create, let's say, a lot more good to the world than maybe the short-term difficulties we might have. And I do think more people are going to be end up working in technology. Of course, we all have to adapt, right, and learn to work the new way. But as long as we do that, I think there is pretty good future for anybody who's in technology, in my opinion.
And as you have been working with some of your customers and early adopters of the Resolve platform, what are some of the most interesting or innovative or unexpected ways that you've seen them apply this agentic capability within their operating environments?
Yes, so this is something that surprised me, even by how our own team is using the product. When we started, we were thinking we're building an AI SRE basically, right? That can be on call, that can troubleshoot alerts, troubleshoot incidents, troubleshoot problems that humans report. And of course, we do this quite well now, and it's very effective. But because we created now this set of agents that essentially are an abstraction over all the underlying data from code to telemetry to infrastructure, humans started using it all the time, what we call like vibe debugging, right? Any question that you have about your code or production system, it's much easier to answer by going to Resolve than going to the underlying systems. Like our own team uses Resolve like all the time, like I just use it multiple times a day to answer any question they have about the underlying software system. Barely anybody goes to the underlying tools anymore. It's way easier and more effective to go to Resolve because oftentimes you have to combine data from multiple systems. But even if it's just one system, Resolve does it a lot faster than a human would be able to do it. So I'm surprised by how much, let's say, usage the product gets. Usage has exploded outside of actually incidents and troubleshooting.
And what are some of the interesting ways that you have been using Resolve to help power Resolve?
We use Resolve for, first of all, everybody's using it. Like Resolve is on call internally. It responds to every alert and incident. Humans use it for any questions they have. Like I said, nobody goes to the underlying tools anymore inside Resolve. But then other surprising things is like our own sales team, they're all power users of Resolve, for example. Instead of like going to the engineering team and trying to get answers about their customers or about features, everybody goes to Resolve and tries to answer all sorts of questions that I never expected. Things like, why is my customer, like, is my customer's environment stable, right? Have there been new users using maybe Resolve? Somebody maybe sees like a new feature on Resolve, right? On the UI, and they go and ask, hey, Resolve, can you tell me what this new tab does on the UI? Or can you tell me how can I use this new integration that was developed? Resolve will give you an answer, right? Like exactly of how can you use it.
Yeah, it's interesting because for a long time, the only people who interacted with the operational systems were the people who built and maintained them because they were the only ones who had the necessary context and, in a number of cases, access to even be able to do that work. And it's interesting how raising the capability of the system to be able to manage itself broadens the scope of who is able to interact with it and the types of capabilities that they're able to gain by virtue of the underlying information kind of generation that exists.
Correct. And I think people have these questions all the time. They would either refrain from asking them because they didn't want to like interrupt somebody, or they would bother somebody and they feel like they're interrupting them for some important work. And I think like essentially AI agents allow anybody in an organization to self-serve themselves and answer any question they have. And in some sense, maybe even like the coding agents, in particular, like the more vibe debugging type of vibe coding type of agents, allow anybody really to create prototypes and experiment with building. And I think the same thing is happening with production systems, with where anybody can ask questions about software, about like features, about they couldn't answer on their own before.
For anybody who has a production system, they're managing it in whatever fashion they have available, what are the cases where you would advise against adopting Resolve AI?
I think that there are still companies because of compliance restrictions or particular circumstances they're in where they haven't gone to the point where they can trust, let's say, maybe AI agents to operate and have access to the appropriate data. So I guess if somebody is not in that position, right, where they can give the agent the appropriate data that the human uses to troubleshoot the system, then it doesn't make much sense, right? Because then it's like tying the agent's hand behind its back, let's say, and trying to have it help humans, right? It's probably not gonna be able to draw the right conclusions. So that's a scenario where we've seen and where we advise against using it, unless you can get to the point where you can obviously to the high. We focus a lot on security. We focus a lot on like making sure the system is conforms to the higher standards of security and compliance. But if that's not sufficient, and it's not sufficient, let's say for a good subset of the data, then it probably doesn't make sense. Then it depends on the other particular situations, right? Where maybe somebody has a very bespoke system that maybe they don't use any standard tools, and maybe like the integrations would be all custom. That also might make it a bit more difficult, right, at this stage of the product evolution to be able to be used.
And as you continue to build and iterate on and invest in Resolve AI, what are some of the projects or capabilities that you have planned for the near to medium term, or any new areas that you're excited to explore?
Obviously, we keep improving the accuracy and effectiveness of the product so it can solve more and more problems. It can get you to the right answer much more quickly. It can give you the remediation and the solution you need to follow. We keep expanding the coverage so it comes out of the box knowing every tool in your environment. And we also improve the capabilities of the product, right? To go and essentially be much more effective and do much more of the work and get you to the outcome or to the solution on its own without maybe a human having to do any work. So these are the three areas where we're expanding constantly. And we're also moving at a very, very high velocity. One interesting thing I tell sometimes customers is that unlike like traditional software, or maybe you get a demo or you saw a product and you more or less knew if it's going to help you, I think AI and especially Resolve AI is moving so fast that it does make a lot of sense actually to kind of start using it because it becomes better, it improves its capabilities, but it also learns. So like even within a month or two of being used in production, it becomes way, way more effective.
Are there any other aspects of Resolve AI, the overall application of agentic capabilities to production systems, or your own explorations within that space that we didn't discuss yet that you'd like to cover before we close out the show? All right. Well, for anybody who wants to get in touch with you and follow along with the work that you and your team are doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gaps in the tooling, technology, or human training that's available for AI systems today.
I think that there is still obviously the reasoning capabilities of models for some of these harder long horizon problems are very limiting, right? And the models are improving and we're improving, like say, the applications and solutions on top of them. And the more that improves, actually the outcomes are going to improve exponentially, in my opinion. But I also agree with you that humans have to adopt, right? And humans have to get used to using these tools. We still see sometimes resistance in organizations, and I think two things are true for that, in my opinion. AI has to be a top-down kind of initiative, and especially so that organizations don't fall behind and get disrupted by competitors. But also, all of us as individuals, probably it's important. This is a time where we should be curious and try to learn all these new tools and capabilities, right? To not fall behind individually in what we do.
Absolutely. Well, thank you very much for taking the time today to join me and share the work that you're doing on Resolve AI. It's definitely a very interesting platform and interesting application of these emerging technologies. I appreciate all of the time and energy that you're putting into reducing the burden of people who are operating production systems as somebody who is responsible for them myself. So thank you for that, and I hope you enjoy the rest of your day.
Thanks a lot, Tobias. I really enjoyed the conversation. Thank you.
Thank you for listening. Don't forget to check out our other shows. The Data Engineering Podcast covers the latest on modern data management, and Podcast.init covers the Python language, its community, and the innovative ways it is being used. Visit the site to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at aiengineeringpodcast.com with your story.